Hello, everyone. Thank you very much for joining in this short guide series where we will be talking about designers as well as developer pain points while dealing with the uh, Unity projects, especially uh, issues related to uh, handoffs, and their implementation inside Unity. So what we will be ensuring pixel perfect Unity implementation of designers mockups without any guesswork. So without further ado, let's move ahead. So what is the objective of this guide? So our objective is very simple to make sure what designers create is exactly what shows up inside Unity with zero guesswork, zero pixel drift, and without any last minute rescaling. Uh, so let's talk about who is the target audience for this. So who should watch? So this guide is for designers making UI mockups or 2D assets, developers implementing them inside Unity, as well as the project managers connecting both sides because after all, project managers should have the common understanding of the contract between the designers and developers that both team has agreed to work with. And yeah, so these three are the primary uh, target audience for this video. And let's move ahead. So we will first talk about the main pain point when it comes to handling the design implementation as well as design handoff uh, between the designers and engineering team. So here's the problem. Designers export beautiful screens, but when the developers bring them inside Unity, things don't line up actually. The UI gets blurry, the spine animations are too big, text looks off, and it takes hours to fix, usually by eyeballing. And believe me, this is one of the hardest thing to do inside Unity to manually fix uh, pixel by pixel, and which could have been achieved through the uh, perfect base configuration. So we will be talking about that. So first of all, why this problem occurred actually in the first place? Because there is no shared agreement on how to hand over or import or scale assets inside Unity. So there should be some kind of agreement between the designers as well as developers beforehand, even before starting the design or development, so that designers know that okay, these are going to be the configuration I need to work with, and as well as developers are ready uh, for implementing them inside Unity. And we will be talking about the solutions step by step, and we will be laying out the pipeline for the asset handover from the design team to the developer team, and with the minimal errors and maximum supporting throughout the different resolutions inside Unity projects. So let's move ahead and let's see what's next. So we will be providing solutions through a shared pipeline with best practices. So we can see there are four. Let me mark them out. So, so we can see there are four important points. Let me draw it for a clear understanding. Yeah. So first we will be talking about the designer's kickoff guidelines, where we will be talking about the different set of ground rules for UI, sprite, as well as the spine asset creation. Uh, this is very important to have the common ground or the common configurations agreed before the developer as well as the designer, so that designers are good to go uh, with their design approach. And once they provide the assets to development team, it should align properly without any further manual intervention. And the next further, we will talk about the designer handoff guidelines, where the assets designed by the designers will be handed over to the development team, and make sure, by making sure all the specs of the art has been taken care before it goes to the developer. Next, we will be talking about the developer's guide. This will be the development heavy point, where we will guide the developers to implement Sprite or UI based mockup inside Unity, along with discussing spine based assets implementation inside Unity also. So we'll be seeing both kind of implementation, canvas based UI implementation as well as sprite based world implementation of the UI, along with spine asset integration inside Unity. And at the last, we will be talking about few best practices uh, for the optimized pipeline, where we will be including few important tips to streamline the flow of developing the optimized art and smart handoff to developers. Uh, so we will be talking about all these four step by step, and we'll try to answer all the possible questions in your mind. And by the end of this video, we should have the clear guideline for designers, for developers to work with the minimal possible errors. Let's move ahead. Well, uh, before before jumping to those points and uh, talking about them in detail, let's first understand what matters in Unity when rendering UI, sprites, or spine assets. Uh, this is very important to understand how Unity renders them assets, in what scenario, what factors are important, and whether designers uh, should take care about this Unity terms while while designing the assets on their systems. So we will be answering them step by step. So first, let's discuss. Let me use the pen. So first, we will be discussing. Oh, sorry. Somehow my pen is not working as expected. Again, let me go back again. Let let's not use the pen. Okay. So let's talk about the Unity's PPU, that is pixel per unit concept. So in order to get the design implemented inside Unity and get the exact match, all it starts with understanding how PPU works inside Unity. So what is PPU? That is pixel per unit. So PP is actually it tells Unity how many pixels in an image is equal to one Unity world unit. So by default, the PPU is 100, that is 1 unit in Unity is equals to 100 pixels. So let me show you through an example. In fact, there is one example already mentioned. So if an image is 200 into 200 pixels and PPU is set to 100 in Unity, then the image will be taking 2 units wide and 2 units tall space in Unity. Let me show through an example to make it very clear. So let's say you have a screen with resolution resolution 1920 height and 1080 width. So inside Unity, how many units these pixels or these resolutions actually represent. So if 1 unit equals to 100 pixels inside Unity, so that means we can represent these 920 pixels by 180 pixels in terms of unit. So it will be 120 divided by 100 equals 19.2 units long, and 1080 divided by 100 units, that is 10.8 units wide. So the same resolution, that is 180 into 1920, resolution can be is equivalent to 19.2 units long and 10.8 units wide. So this is simple. So 1 unit is exactly equals to 100 pixels inside Unity. Say, uh, let me erase this. Let me redraw this again. So if this is our screen, which is 1080 into 1920 of resolution, and if there is a box of resolution, say 100 pixels wide and 100 pixels height. So if we need to put these boxes, in fact, number of boxes inside this resolution, so how many boxes it should contain? So it should contain, you know, so this 100 by 100 actually represents equals to 1 unit inside Unity, and the length of the screen is equals to actually 180 divided by 100. That is the default PPU that is inside Unity. So it will be 10.8 units. So in 10.8 units, we can have 10 units of this box. Mark this with a different ink. Yeah. So we can have 10 boxes, 2, 3, 4, dot, 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 10 boxes. After the 10 boxes, there should be 80 pixels left because this is exactly 10.8 units wide, and this area is actually 1000 pixels covered by 10 boxes, and still 80 pixels will be left because we do have 80 pixels extra. Similarly, if we put boxes vertically, it will take around so 19 boxes vertically. So 19 means it will cover 900 pixels vertically, and still 20 pixels will be left. Still 20 pixels will be left because it has 1920, so 20 pixel is extra. So you can understand that this is all about just understanding how many pixels can be covered by different sprites or images uh, inside a fixed resolution. So this was all about PPU inside Unity. And now comes to the main question, whether the designers should take care about this PPU thing while designing the 2D assets on their platforms. So answer is actually no. They don't have to take care about these things. This can be automatically can be taken care of or by the Unity or by the developer if and only if the designers follow all the uh, design and handover guidelines properly, then they don't have to think about this CPU thing inside Unity. But I have explained it for the sake of understanding how Unity renders the different UI and 2D assets inside Unity, so that uh, designers can even relate to the issues easily when it comes to uh, tackling any issues happening between the designer and developer. So let's go back to our presentation. So yeah, so and one more important thing to consider that PPI, that is pixel per inch in Photoshop, is not equals to PPU inside Unity. They are completely different terms, and they do not have any relation between them. So, and for some reason, if we avoid or miss the PPU setup inside Unity, so it can create a lot of inconsistencies, like UI elements do not match the designer's intended size. You'll get misaligned graphics or wrong aspect ratios. Textures can look blurry or pixelated. Different screen sizes will scale UI incorrectly, and lots of issues. So let's move ahead and see what kind of guidelines we can set for designers so that they can start working on their designs. Let's move ahead. So we will start with the first point, that is designer kickoff guidelines. So in this section, we will be talking about what are the before production rules we usually set for UI, sprites, and spine asset creation. So let's move ahead and see the points step by step. So we will be talking about the UI and sprite design guidelines and spine at the end of this. So we will be talking about them separately. So first, let's focus on UI and sprite design guidelines. So first of all, use a fixed design resolution. So always design for one fixed resolutions like 1080 into 1920 if we are targeting vertical screen, or 1920 into 1080 if we are targeting the landscape screens, or these resolutions are just for reference purpose. This is something you need to have discussion with the developer and to find out the common fixed resolution that both designer as well as developer is going to use, and it will be used throughout the design process and development process. So this is very important to have the fixed resolution in place before starting the design. This will be ultimate reference resolution inside Unity when it goes to developer to implement those mockups inside Unity. Design at 1x scale 100%. It is recommended to design those assets at 1x scale and avoid scaling them 2x or 3x unless it is required for Retina on HD exports. Most of the times we do not need 2x or 3x. All we need 100% scale to be shared with the developers. Export in actual pixel sizes. Example, the button is 200 into 80 pixels in design. Export as 200 into 80 PNG format. So export them exactly with their original size, and there is no need to scale up and down during export. Moving ahead, Regarding UI assets, if we are working with the UI assets, use slice guidelines, especially for those assets which needs scalable features like buttons or panels, uh, and stick to sRGB color profile, no embedded profiles and exports. Uh, so it will make sure that the color combinations are properly matched and it can be replicated inside Unity. What about the void space sprites and spreadsheets? Obviously, apart from designing UI screens and mockups, we often designers often need to work with the 2D characters, uh, the sprite-based 2D characters, sprite-based 2D character animations, which we also call the sprite shades. So, what are some best rules to work with them? So first of all, create a sprite sheet for animations using texture packer software. So we usually create the sprite sheet animation sequences and pass to the developers to use them directly inside Unity, but that is not an optimized way. So designers should be able to create the uh, sprite sheet for the animations using the texture packer software that I will be talking about it a little later. And apart from that, in order to pack different assets, say different UI elements, texture packer again can be used for packing them with the maximum efficiency and with the less size. This is a very important point that use power of two sizes. Uh, Whenever we get chance, so we should always try to stick with creating the assets with the power of two resolutions, like 32 by 32, 64 by 64, 128 by 128, 256, 256, 512 into 512, and so on. So these resolutions are actually help to compress the images, and thus it reduces the build size and helps to optimize the build. Next, moving ahead, we will talk about the spine asset design guidelines. So we designers usually create 2D animations inside spine software. So sometimes we have seen that those spine animation gets scaled at the different resolution or the different scale that when goes to Unity, it doesn't match with the actual markup. So what should be the reference or the configuration in order to create these spine assets? So base your spine project on the same resolution with which those UI mockups have been created. For example, 1080 to 1920. So while animating your 2D assets or characters inside Spine, keep a reference screen frame that is 1080 into 1920 as a background guide. That way, you will be able to identify whether your character is being scaled or not, and it is in the correct size or not inside Unity to match with the Unity scale later, and always export at 1x scale from spine. So let me show you what I mean when I say we should have the background reference while animating inside spine. Let me delete all this. Okay. So maybe you are working with a 2D symbol or 2D character inside spine and animating them, but we should have a background reference image of the same resolution with which we have created the UI mockups. This ensures that our scale of our spine assets or the spine animations are in line with the its with the base resolution of the UI mockups, and it will not be further scaled up or scaled down. and designers will be uh, ensure that they are passing the correct scaled assets to the developers. So they should be using this 1080 into 9020 pixel wide background image. So that's it. And spine animators do not have to do anything apart from this. All they have to do is to use the background reference resolution, and that's it. And finally, export all the assets at 1x scale. This is very important. So finally, we are done with the designer kickoff guidelines. Next, we will be talking about designer handoff guidelines. So in handoff, we will be having checklist ensuring all aspects of the art have been taken care of before it goes to the developer. Basically, all you need to make sure that you export all the assets at 1x scale and use nice slice guidelines for the buttons or panels wherever required. Apart from this, you don't have to do anything because you have already covered uh, all the important points inside designer uh, guidelines. The first we have discussed before that. And in order to deliver the design assets to the developers, we have often seen that designers use chat channels or the emails or the WhatsApp or the other chatting channels to pass the images to the developers. This is not the optimized way because first of all, it reduces the quality of the assets when we use such kind of channels to transfer the assets. And second, it creates a lot of repercussions because it needs you need to pass a lots of images, and developers end up having several versions of the same images in their projects, and it creates a lots of redundancy in their project, which could have been avoided if we use any kind of asset delivery software like Zeppelin. It's a platform where we can, mm, you know, primarily used as a design delivery platform to streamline the process of sharing and collaborating on UI UX designs between designers and developers. It helps to bridge the gap between designs and development by providing an structured and organized workspace where teams can access design specification, assets, and style guidelines. I'll be talking about this a little later. So this is just a suggestion on top of this. Finally, we jump to the developer's guide, that is how developers should work in order to matching the mockups that they have received from the designers. So the designers can skip this section if they want. If they want, they can stay with us in order to understand how Unity developers work. But otherwise, they can skip this section and come back directly on this part. That is the last one. So let's talk about the third topic, which is best practices for developers to implement Sprite or UI and spine-based assets inside Unity, and to match with the actual mockups without manual intervention. So we will talk about the Canvas as well as non-Canvas based solutions, and also we will talk about the spine integration. Oh, well, so first we will talk about the Canvas-based UI or the Sprite implementation. So first of all, we got the mock-up from the designers with the resolution, say 1080 to 1920. We know that we are about to set pixels per unit equals to 100 in Unity, which is by default already. So you don't have to do anything in that. And we will use the uh, responsive UI for scaling the screen sizes depending on different resolutions. So let's see directly inside Unity how we can implement the assets with an example. So we will see how we import these sprites, how to set the pixels per unit, and some suggestions to disable the mismatch because this is not good for UIs. And we will set the filter mode to either point or bilinear depending on what kind of output we want, whether pixelated or non-pixelated or smooth edged art. So depending on that, we can use the filter mode. So let's go back to Unity. I do have one example ready already, just to showcase. Let me show you. Is that there? It is. So let's say we want to implement this UI inside Unity. So let me use a pen tool. And yeah, so let's say designer has given us this UI mockup where the background resolution is 1080 into 1920. This character is 400 into 300 pixels, and this button is 300 into 75 pixels. So we have already exported these assets and imported inside Unity. So let me show you. In fact, I need to import this, so let me directly import. So we have BG, we have the character, we have the button. So if we click on this, so we can see the BGs. Set, let me first check. This is 1018 to 1920. Button is 400 into 75, while the character is 400 into 300. And we will replicate the same output that we have seen in the mockup, and it should look exactly the same without scaling any assets inside Unity. All we need to just put this onto the specific predetermined place, and it should give the same output that we can see now. So let's go back to Unity. So we do have these sprites. All we need to first do is to convert them a traditional sprite by selecting them all, or maybe one by one. Let's select them all. Set texture type as a sprite 2D and UI. Set sprite mode as single. Mesh type as full rect. And we can reduce the extrude edges. I don't want to leave any extra space around our sprites, and hit apply to convert them into sprites. So now we do have the background, the button, and the character, and we are going to implement them inside Unity as the part of this canvas-based UI implementation. So we will be using the canvas. So let's set up the canvas first. Right click UI. Yes, canvas. So here we can see there's a canvas scalar component, and here we have to set UI select scale mode as a scale with the screen size. Now we have to put the reference resolution here. So This resolution will be exactly same with which the designers have created the designs, which is 1080 into 1920. Uh, let's match the width and height with a balanced number that is 0.5. It should make sure that height and width both are taken care of equally. And we are setting reference pixel per unit as 100. So that means we are indicating that all the assets we are going to use are going to have 100 pixels per unit as their configuration or the setting. So if we select these assets, we can see these are already marked as pixel per unit 100. So by this is the by default value, and we do not have to do anything until and unless required. So let's create a panel. So UI panel and assign this background image. This, and if we drag, if we now let's put the character using the UI image. Let's name it character and drag and drop this character onto the source image. The next, we need to click on the set native size. That is, it will try to expand to its original size, that is 400 wide and 300 tall. So let's click on set native size and it will take its proper shape. And all we need to just place at the proper position according to the mockup. Uh, this looks okay. The next is to bring a button. So let me create one more. Let me put inside panel. Let me create one more image to hold the button. Image, say button, and drag and drop this button image. Again, we need to click on set native size to get the proper height and width for this sprite and just put it at the proper place. Or we can use these anchor points to properly place these assets with respect to the bottom point of the screen. Now you can see that without scaling anything, you can see we did not scale any object and it took its original width and height as it was exported with, which is 400 into 75 for the button, 400 into 300 for the characters, and this this DG is actually taking the full space. But what we can do, we can have this separate image for the DG just for making sure it takes the space properly. So this name is DG, put it at the back, drag and drop this DG image, and click on set native size. So you can see that this has taken width 180, 1080 into 1920. So we have able to achieve exactly the same mockup that we have created inside our uh, design platforms. So this way we can make sure that UI based mockups uh, can be implemented without scaling any sprites. So this was the example for UI, but sometimes we need to work without UIs in the world scale actually. So let's see that how we can implement this in the world scale. Let me go back to the presentation. So this is something we have already done. So one thing that I missed was to set the camera as the orthographic, because in 2D, if we are targeting 2D projects, all we need to use the orthographic projection, and it should be fine. Uh, we need to deal with the size when we start working with the world units. So that is something we are going to see in the next section. So this is already we have done. We have set camera to orthographic. We have matched the anchors. In fact, you can use the anchors and layout groups for responsive design, responsive UI designs. You can use this sprite packer or the atlas if needed, but maintain the same PPU, that is 100 PPU inside Unity. So if designer creates a 100 pixel wide icon, it should appear as exactly 100 units in size inside Unity UI canvas. If and only if the PPU reference resolution and canvas scalar matches. So we have seen that we have implemented and everything matched. So we are good with this. So moving ahead, now we will be talking about non-canvas based sprite implementation. Uh, so here the process is exactly same as it was earlier. Texture type should be sprite 2D. Pixel per unit should be 100. We will disable the mip maps and we will set the filter mode to pointer by linear depending on our art type. The important point comes in non-canvas based sprite implementation is setting the camera orthographic size. So orthographic camera setup in Unity is absolutely critical if you're working with world space sprite that is non-UI canvas and want them to visually match a mockup design at the same resolution. So let's go back into Unity and set the camera to orthographic that we already did. And what is the next step? A 1920 into 180 pixel mockup to appear 19.2 and 10.8 unity units in size, assuming PP is set to 100. To achieve this, your camera must be configured so that the visible screen area in Unity units matches the mockup size in pixels. So, what is the orthographic size formula? It is target screen height in pixel divided by PPU and whole to be divided by 2. So if resolution is 1920 into 1080 pixels and the PPU is 100, that means we do have uh, height 1080, that is to be divided by 100, and that is to be further divided by 2, which will yield the result 5.5, which we need to assign as the orthogonal camera size. But in our case, the resolution is the reverse 1080 into 1920. So let's find out what should be the orthographic size for our project. Say if our resolution is this, sorry. So orthographic size should be height divided by CPU and whole to be divided by 2. So in our case, the height is 1920 and TPU is 100. So let's recalculate. So 1920 divided by 100 whole to be divided by 2, which is 19.2 divided by 2, which will give us the final result 9.6. So this will be our camera size for this resolution. So let's set up 9.6 as the camera size. 9.6. I'll show you one other uh, shortcut where you don't have to calculate the size. It will be automatically taken care by Unity. But let's first see this. Now next. So this time we are not using Unity UI canvas, so we can directly drag these sprites to the world positions. Make sure our main camera is set to 0, 0, 0. At least in X and Y, in Z it can have some depth to render the objects in front. So we dragged this BG2 sprite into space and set the position to 0, 0, 0. If we go to the game view, we can see it has already taken the whole space because we have set the camera size according to the target resolution, and it should automatically take the whole space for the background. Next, if we drag and drop this cartoon character and yeah, just increase the layer. So you can see without doing any scaling, it is already fine with the scaling, which is matching with the actual mockup. Let me just drag, not drag the buttons. Let's see, drag the button, increase the layer to make it visible, drag and drop. Now, if we go back to the game view, we can see we have got the same output without doing any scaling. And all we need to just set up the main camera properly and set the PPU to 100, which is actually there by default. Apart from this, is there anything else? No, we have been able to cover UI-based canvas implementation as well as non-canvas based sprite implementation, and we have got the similar result. Now, when it comes to spine asset implementation, uh, we we are ensured that designers have given the assets of the required scale and and created those assets by taking the background uh, background resolution with which the UI mockups have been created. Once that is fine, now we do have two options inside Unity: to use the skeleton directly in world space or to use them inside Unity canvas. So if we are using them inside Unity world space, we can use the skeleton animation and we can set the skeleton data set uh, and its scale equals to 1 divided by PPU. So if our PPU is 100, so 1 by 100 equals to 0.01. So make sure the scale of the skeleton data set is set to 0.01 and it should work fine. In case of Canvas UI, we will be using skeleton graphic, which actually help it to integrate inside Canvas, and you can just use inside unit UI hierarchy. This is important to mention. We need to set the size and position using the rect transform. When we use any asset, whether sprite or spine inside Unity, the rect transform is actually the boss. So we need to ask the rect transform that we want to have. Let me show you a quick example. If you are using canvas and inside that there is an image and assign this dog image to this UI image and set its native size. So inside canvas, every image or element Its height and width is actually controlled using the rect width and height mentioned inside the rect transform. So we need to provide exactly the same width and height of the asset with which we have received them in order to make them visible with the same scale. And with these 2 points, we will be able to use these spine assets inside Unity with the same scale that has been there inside the mockup. Finally, we will be coming to setting the correct color space in Unity. So color space actually defines how colors and brightness are interpreted. So there are two main color spaces inside Unity. The first one is gamma color space. So gamma is mainly used for the 2D and UI heavy games where we need the correct level of brightness and the color variations. It is actually non-physically accurate and it is simple and fast. It doesn't account for how human eyes actually perceive brightness, but this is good for 2D and UI games. So we will be staying with the gamma color space for 2D and UI games. If we are dealing with the 3D games, where we need physically accurate output or the real world lighting effects, so we will stay with the linear color space inside Unity. So we are done with the 3 points designer kickoff, where we have shown the guidelines for setting the configuration with which the designers needs to start the design. We have seen the design handoff guidelines where the designers can share those assets using uh, some intermediate platforms like Zeppelin that I'm going to talk as the next point. Then we have seen the developer's guide to implement UI, non-UI, and spine-based assets. Finally, we are going to have quick discussion on best practices for optimized pipelines. So let's see that. The first suggestion is use texture tracker for efficient sprite or spreadsheet packing. So for performance, use toolkit like texture packer to bundle UI icons and sprites into atlases. Along with that, it creates optimized spreadsheet form sequences to directly import in Unity using the free texture packer plugin. So if we go to its website, so this is the texture packer software, and this is highly recommended to have this software with the designers because it helps to package the assets very tightly so that it takes less space and still without losing its quality. So like you can see there's an example having all those assets are packed very tightly and it can have it creates the sprite sheet with the optimized output. Like in Unity, we can see if the if we provide the sprite sheets with the traditional method, so we can see there is a batch count is 10 and number of tries is 138. But we if we pass the same sprite sheet which is created using the texture packer, we will end up having a lots of efficiency in terms of CPU as well as GPU cycles. So we can see the batches as well as price count has been reduced drastically, which will obviously help to keep our games running smoothly at the fixed frame rate. Apart from that, it has a lots of features like pivot point editor. We can change the pivot points easily without going back to the design softwares. We can even nine slice the images to be used inside Unity UI. for scaling them without losing or looking stretchy. And apart from that, it has many features. So I would be suggesting we should have this texture packer along with the designers, and it will be very helpful for the team. And the final suggestion is use 2D asset delivery platforms like Zeppelin. So using Zeppelin workspace, uh, each project can have the separate workspaces and assets can be delivered through the same workspace. Stakeholders can have a look, approve, or give modification requests via workspace through comments, and developers can easily directly inspect and download the 2D assets. Uh, we have seen that the designs goes back and forth between the developers through the unit through the teams channels, and developers end up having many versions of the same uh, assets in their projects. Uh, so there is a high chance that there will be the mismatch between uh, the designs, what has been approved and what has been delivered. So we should find out the common place where we will share all those designs, get it approved and passed to developers so developers can download them, can see the configuration of those assets, height and width in terms of pixels, so that they can set it correctly inside Unity to get the same output as the markup. With this, I guess we are done with this video. It was a little longer, but I guess it was helpful. And thank you very much. Bye.